I'm always wondering what weird noise or comment are people going to make when the video starts.
It's Liam.
Now everybody knows.
Oh, it is turned. I thought it wasn't turned. It's on that.
The R.I.P. Ronaldo was great.
Oh.
I was in there.
In
memorial.
Yeah,
All
I
right.
commented that.
So again, like I said a minute ago, this is where the we start to really kick it into gear a little bit.
So now it's gonna become hard again, pretty much. It's not an easy day.
Yeah, in my opinion, section 8.1 is easier than sections 8.2 and 8.3. But some of you are going to struggle with it.
Come on.
I am someday.
I believe you will have calculators for this entire chapter. I believe so. Don't quote me on that, but it is recorded.
I gotta quote that.
And you're the teacher. We trust you.
But I believe we get calculators for this entire chapter. Okay. All right, here we go. So this is a topic, this beginning part of this lesson is a topic that you learn in Algebra 1. I know it. You definitely have. Because I teach it to my Algebra 1 students in like the second 9 weeks. Okay? Do you guys remember direct variation?
Yeah, but maybe.
Okay, direct variation is just a linear function that basically has no y-intercept. Has a y-intercept of 0. A direct variation is y equals a number times x. Like y equals 3x, or y equals 5x, or y equals 10x. Okay? That is what's called a direct variation. Oh, we did that in here too, didn't we? In chapter 2, we studied many types of linear functions, one special type. Now, again, a direct variation is a special type of linear function. Not all linear functions are direct variations. Take y equals 2x plus 5. That's a linear function. It's not a direct variation because it does not run through the origin. Okay, a direct variation is a relationship between two variables, x and y, that can be written in the form y equals k times x, where k is non-zero. So y equals negative 3x is still a direct variation. Y equals 5x is a direct variation. Y equals a number times x. Now, we can say that as y varies directly as x. Y varies directly as x. Now, how does it vary? Well, it varies by the constant of variation. The constant of variation is that number multiplied by x. So if it would be like y is equal to 3x, 3 would be the constant of variation. Y is equal to 0.1x, 0.1 would be the constant of variation. Y is equal to negative 5x, negative 5 would be the constant of variation. Constant of variation. And again, we state it as y varies directly as x. You're going to see this phrase, and I'm going to replace x and y. I should restate that. If you see that phrase, something varying directly with something else, that means that it is it's in this y equals kx form. It's a direct variation. Okay? We're going to learn other types of variation, but this is what's called a direct variation. A direct variation equation is a linear equation in the form y equals mx plus b, where b is 0. We talked about it not having a y-intercept, or the y-intercept being 0. It has to run through the origin. Every single direct variation must run through the origin. If it does not, it is not a direct variation. The constant of variation k is considered the slope. So if it's y equals 10x, obviously m is 10 in this case, the slope of that line would be 10 over 1. Always pass through the origin. Again, direct variation, y equals kx. Constant of variation, y varies directly with x. You're going to need to know. Ooh, apparently that's all tied together. Well, not anymore. There you go. Okay. Make sure you know that phrase. That's a main key phrase that you're going to need to know. Y varies directly as x. In this section, we're going to have a lot of word problems, a lot of application problems, and I'm going to tell you, speed varies directly with time, or circumference varies directly with diameter. Guys, what's the constant of variation with circumference varying directly with diameter? Pi, right? C equals pi d, right? So a constant of variation is just that number that the factor that it varies by, right? Okay, so direct variations come up a lot. They just don't have a y-intercept. There's no plus or minuses in it. Okay. All right, so given y varies directly as x and y is 27 when x is 6, write and graph the direct variation function. I do this question, like this could have been on my Algebra 1 Chapter 5 test. Okay, given y varies directly as x, this phrase right there tells me that I have the equation y equals k times x. Now, what's unique about this is the next phrase gives you a full ordered pair. I say y is 27 when x is 6. That will tell me my constant of variation. Okay. So y is 27 where x is 6. How do I solve for k? Divide by 6. 27 divided by 6. Let's put it back into fraction form. 9 halves. 9 over 2 is equal to my k value. Yeah.
It's beautiful.
That's just a really chair. That's just a really
How are all my letters on that line? Is that okay? Good. Thank you. I'm glad I can help. Y is equal to 9 halves x. So that's my equation. Right? Y equals 9 halves x. Y is equal to 4.5 x. I'd like you to write things in fraction form more over than decimal form, especially when it's not an application problem. If it's an application problem, you got to use decimals. That's fine too. Okay, now write and graph the direct variation function. So there is my there's my equation. There's my function. We know that if it's the direct variation, it must run through 0, 0. Plot that point, right? And then 9 halves is the slope. That's why I ask you to write it in fraction form. Up 9 over 2, or I could go down 9 left 2. So there is my direct, that was a good line, direct variation. That make sense? Good. Try one on your own here. Try to make the equation. The perimeter P of a regular dodecagon varies directly as the side length S. Perimeter, if perimeter is 18, side is 1.5. Find S when P is 75. Okay, guys, how many sides does a dodecagon have?
12.
12 sides. What's my K value? Because we know perimeter varies directly as the side length. Right? So P is equal to KS. The perimeter P varies directly as the side length. P equals KS. Now, if P is 18 and K, we don't know, S is 1.5, I divide over the 1.5, and guess what? 18 divided by 1.5, oops, that's 2. 1.5 is 12, which makes sense. What is the perimeter of any regular figure? It's that many sides times the side length. So if the dodecagon has 12 sides, then the side length is S. It's P equals 12S. Simple perimeter formula. Okay. When P is 75, .25. I'm okay with the decimal here. Inches. Make sense?
Are you gonna like
I'll say if it's an abstract problem with x's and y's and stuff, give me fractions. If it's real life, I'm okay with decimals. Yeah. Real life. Okay, joint variation. A joint variation, two things joining together, right? A joint variation is a relationship among three variables. They can be written in the form y equals kxz. Okay, now that we've got three variables, graphing goes out the window. We don't talk about that anymore. We could do three-dimensional, but let's not get into that. Y equals kxz. Y equals kxz. That is saying y is varying jointly with x and z. Okay, y is varying jointly with x and z. We still have a constant of variation. Okay. So the key phrase is y varying jointly with x and z. Another way to say this is y varying directly together with x and z. You know, y varies directly as x and y varies directly as z. If I say two things are varying directly to the same thing, then you can say they're varying jointly together. Y varies jointly as x and z.
I thought we were done around this, like,
Let's go.
like, I thought, like, I finally, like, got out of that groove, like, there was, like, a good, like, week and a half.
I know, it's back again.
That's good for program.
Okay, yeah, the Corona's gone, all three people up in Cleveland, yeah.
They're coming for us.
Yeah, OSU closing, yeah.
I'm excited for it, dude.
Hi.
Hey, my dad's gonna go on a business trip because they canceled the Ohio Safety Congress, so it's a big trade show.
Well,
The only
Hey, you're
issue
going to
is
that,
causing
right? He's like, okay, they canceled that, so you should like not go.
compromise.
Wendy, what is
Which
school?
the flu competition,
Wendy, what is the school?
Yeah. Yeah, Springer and Bud.
Hey, I'll tell you what, if the school does, I mean, I am set up to teach online. So like you guys, that's enough.
What if somebody accidentally breaks your computer?
Somebody accidentally, oops, if Cooper version, I walked up and threw my computer on the ground.
Oh, now the FBI's gonna come.
So I'm sorry, guys, if we go online, I'm gonna be getting you guys videos every day.
Now I'm gonna get ads for
Sorry.
Now that you mentioned me breaking things, I'm getting ads for them.
Yeah, really.
If that happens,
Yeah, you know.
it's there already.
At least you subscribe to
That's true.
I know everyone's gonna be watching that.
Yeah.
Yellow journalism.
I'll probably be making the videos and then like the other teachers will just be like sending, putting links in my video.
Yeah.
All right. That's right. All right. Shh. The volume V of a cone varies jointly as the area of the base B and the height h. Try to write your equation. The volume V of a cone varies jointly as the area of the base B and the height h. Just try to write your equation. You don't have to solve for k yet if you don't want to. If you want to, go for it.
Well.
Curse your words.
If you took a poll, like, I would be.
That's just because people aren't smart enough to understand.
I actually like
That's fair. That's fair.
Which one is a better? Like this.
Or I thought we were talking about.
Wait, what about
pie,
the
like
capital
pie or-
Yeah, like I like chocolate peanut butter.
Oh, yeah.
Okay.
Yeah.
That's the good stuff.
How could we just?
Only Heartfield Kitchen chocolate peanut
How could we just answer this?
E-Day.
butter. Okay, yeah, 2.71.
Yeah.
Oh, that would be like
So-
February
so-
7th.
No, February 71st.
No, it's actually gonna be March, it's gonna be like March, because you have to like, it's like an improper fraction.
on the same day?
Improper fraction.
Or the 27th month.
You could really say it's like February 7th at 1/8 something.
We're doing
Yeah.
that.
Oh wait,
next year.
no, 1/8, that doesn't make sense either, so.
Academic challenge party.
Got it. All right, volume of a cone varies varies jointly as the area of the base B and the height h. K, B, H. Right, just multiplication. K times B times H. All right, now it says the volume, 12 pi, when the base is 9 pi, and the height is 4. All right, now I divide everything over to the other side, right? I could simplify here if I really wanted to. 12 pi is equal to 36 pi k, because again, it's all multiplication, so I can do things in any order and change groupings as much as I really needed to here. So what can I do with my pi's? Cancel them out, thank you. I divide by 36, so I get 1/3 is equal to k, which makes sense. You guys know the volume formula of a cone? 1/3 area base times the height. Volume of a cone is 1/3 area of the base times the height. Okay, now find the area of the base when the volume is 24 pi and the height is 9. Again, I can reorder here. So on the right side, I'm just going to simply make this, 24 pi is equal to 3b, at 1/3 of 9. And then I divide over the 3 to get 8 pi is the area of my base. 8 pi feet squared. So that's y varying jointly. Another way to have said this would be the volume varies directly with the area of the base and varies directly with the height. You can say two things separately varying together with the same thing. That's just called varying jointly. Okay? Those two things are synonymous. All right, now we've got varying directly, we've got varying jointly, but now we're going to talk about varying inversely. Okay, and now this is where this entire chapter lies. A third type of variation describes a situation in which one quantity increases and the other quantity decreases. As I increase one quantity, the other quantity will decrease. For example, the table shows the time needed to drive 600 miles decreases as speed increases. Right? So if I increase my speed, the time it takes to get there is going to decrease. If I set my distance, right? If I know I've got to travel 600 miles, and I start increasing the speed that I want to average, my time that it takes to get there will start to go down. So as one thing moves up, the other thing will move down. That is something that's called an inverse variation. I increase my speed and I decrease my time. Something is going up and as something, and it's causing something else to go down. Okay, they have an inverse relationship. Again, this is called an inverse variation. Let me move all this junk up here. Okay. I don't know. Oh, yeah, there we go. Much better. Okay, so this is called an inverse variation. Y is equal to k divided by x. Notice something interesting? The x is in the denominator. Have we ever had an x in the denominator? No, not so far. Not yet. And that's where this entire chapter is. If you put x in the denominator of a function, life gets kind of weird. Weird things happen. Again, the key phrase here now is y varies inversely as x. Y varies inversely as x. The constant of variation is still k, but now I am I'm dividing by the x value. Y is equal to k divided by x. Y is equal to k divided by x. All right. Can we try an example of this? It's time. It's time. Given y varies inversely as x, and y is 4 when x is 5, write and graph the inverse variation function. So same exact thing as a direct variation, but same way of solving as a direct variation. We're going to make the equation y equals k divided by x, and now I'm given a coordinate pair. What's that? So what do I do? multiply, thank you. K is 20, right? Y is 4, X is 5, K is 20. So this gives me the equation, Y is equal to 20 divided by X. Okay, so what does this look like when we graph? Well, if we ever, don't know what something looks like, we just start running numbers, right? That's what, we had this little discussion at the very beginning, plus what is X to the X? I just started plugging in numbers to see what happened. Let's just plug in numbers to see what happens, okay? I'm going to even go a little bit further and strategically pick my X values, because I want X values that will divide 20 evenly. So like -10, and 9, 8, 7, 6, 5, -5, -4, -2, -1, 0, and then 1, 2, 4, 5, 10. Yeah, I'm going to pick a lot of numbers because I really don't know what's going on. I've said that this is really weird, but these are very easy to divide 20. Watch how fast I can do this table. This is -2, this is -4, this is -5. 20 divided by -2 is -10, -20. I'm not going to be able to plot that. 0, well, is undefined. Ooh, yikes. What the what? That's undefined. If I plug in 1, 20 divided by 1 is 20, divided by 2 is 10, divided by 4 is 5, divided by 5 is 4, divided by 10 is 2. So let's plot these values. -10, comma -2. More. -5, comma -4. -4, comma -5. -2, comma -10. And then obviously we'd have -1, comma -20. Then we have 1, comma 20, 2, comma 10, 5, comma 4. 4, comma 5, excuse me. I guess I would have, whatever. 4, comma 5, 5, comma 4, 10, comma 2. Say what? So here's what we have. Whoop, I missed that. That is what any rational function will look like. Okay? It's actually got two distinct sections. This is a discontinuous graph. Something that will break. Right? Something that has a gap in it. Where is the gap? 0. Guess what? I have a vertical and a horizontal asymptote happening. I have both a horizontal asymptote and a vertical asymptote happening at the same time, separating it into two distinct sections. Okay. Now, that's what we will be studying the entire chapter. The ins and outs of everything that we have here. We'll transform this, be able to calculate what the asymptotes should be, figure out where they go. Oh man, it's gonna get fun. Okay, but for right now, we're stuck on this whole variation thing. Okay, now if I wanted to solve for the k value, okay, we're going to stick on this variation track. We'll get into more, what is a rational function a little bit later. But let's stay on this whole variation mode. Direct variation and inverse variation. So if I wanted to tell the two apart, if I wanted to figure out what my k value was, knowing that it would be a direct variation or knowing that it would be an inverse variation, it's a pretty easy calculation. If I know that it's a direct variation, all I need to do is take y divided by x to find my k value. If I know that it's an inverse variation, all I need to do is take x times y to find my k value. Okay? If I know that it's one of the two. Now, joint variation, I'm not going to worry about this just quite right now. Notice that in direct variation, the ratio of the two quantities is constant. In inverse variation, the product of the two quantities is constant. So in a second, notice you can see it in the next slide there. I'm going to give you a table of values, and I'm going to ask you, what is it a direct variation? Is it an inverse variation? And if so, what is the k value? It could be neither of the two. I'm not saying this has to be one or the other. I'm saying show is it a direct variation, show is it an inverse variation, and then decide which one it is, and then write the function too. Determine whether each data set represents a direct variation, an inverse variation, or neither. All right, so let's try direct variation first. Let's see if there's a constant k value with all of my coordinates. Well, what would the k value be for a direct variation again? Y divided by x, right? Okay, so that means I've got 8 divided by 6.5. It gives me something weird, 1.23. I've got 4 divided by 13. Something weirder. Okay, do I even need to check the last one? Not a direct variation. Wonder if this is going to be inverse. It might not be either. Okay. So let's check here. What do I do now for inverse variation? I see if the product are constant. 8 times 6.5, 52. 4 times 13, 52. Half times 104, 52. So this is an inverse variation. This does check out for inverse variation. Now, let's write what the inverse variation should be. My constant of variation here is 52. So y is equal to 52 divided by x. Okay. Questions about that? Now, that's if it is a direct or inverse variation. This could come out to be neither. Right.
If it's neither, you just scream.
Try that one.
It's gonna be neither. Oh.
Whereas y divided by x, not x divided by y.
Yeah, I knew that.
Never mind.
I'm not calling out anybody specific, just watch my calculators.
Yep, we did that too.
It
couldn't be.
It's gonna be me. I don't know who he's looking at.
Oh, wait, well, that way too, never mind.
Okay, what's y divided by x? 30 divided by 5? 6. 48 divided by 8? 72 divided by 12?
Oh, no, it's.
Oh, gosh. Yee.
Whoa.
At least we're not doing this on Friday. Friday the 13th.
Oh.
All right, questions about that? Okay, one more type of variation. Combined variation. Yeah, but this one's just, it's all in the name. Combined variation. You just combine them all and just kind of mix them all up. I could keep giving you variables and telling you whether they're direct or indirect. Sorry, direct or inverse. And anything direct should go in the numerator and anything inverse should go in the denominator. Right? It's a relationship that contains both direct and inverse variations. Quantities that vary directly appear in the numerator. Quantities that are that vary inversely appear in the denominator. Like for example, if I said, okay, y varies. Now, whatever variable you start with, if I make that phrase y varies, that means that your y value should come first. It should be y equals. So if I say y varies directly with, so k always goes in the numerator, right? K was in the numerator for inverse variation, and there was no denominator for direct variation. So k always ends up in the numerator. So I say y varies directly with x, and a varies inversely as c, varies inversely as d, varies directly as y. Oh no, I can't use y, I just use y. And varies directly as z, varies inversely as t. I could keep going with that. Anything direct would be in the numerator, anything inverse would be in the denominator. Right? K always happens. Oh, geez, I just lost it. I just thought it would be over
I'm done.
I'm just gonna go back and watch it.
there. I just need to take a snap right now.
I just need a snack.
All right, so let me say that again. Anything that I say varies directly will happen in the numerator, and anything that I have say varies inversely happens in the denominator. K always is in the numerator. Okay, so y varies directly as x, varies directly as c, varies inversely as a, varies inversely as b, varies directly as z. Just filling random letters. Yeah. Oh yeah, no. I'm not saying like this is like
the
a
whole
rule or
equation.
anything. I'm just saying all I'm doing is putting direct and inverse together.
Now you gotta label it.
Try to make this equation.
Beautiful.
Oh,
Wait,
Yeah,
where am
no.
I?
There's like two
No.
variables.
Thank you.
Come on, this isn't bad.
The volume V of a gas varies inversely as the pressure P and directly as the temperature T.
Okay.
Just two variables. The volume V, so V is your Y in this case, V is equal to. The volume V of a gas varies inversely as the pressure and directly as the temperature.
Wait, directly, so it's T.
I think we are. I'm always there. Nobody remembers boils.
Okay, K happens in the numerator. Okay, inversely as the pressure P. Where does P go? In the bottom. And directly as the temperature T, excuse me. Volume is equal to KT over P. Now, a certain gas has a volume of 10 liters at a temperature of 300 Kelvin and a pressure of 1.5 atmospheres. Can I solve for K in this case? Yeah. Multiply the 1.5 over to the other side first. I divide by 300. Oops. 0.05. So 0.05 is my K value in this case. Now, that means my equation turns now into volume is equal to 0.05 T over P. If the gas is heated to 400 Kelvin, with a pressure of 1, what's its volume? 20 liters?
It's whatever it wants to be.
20 liters.
Microliter?
Yeah.
I'm glad they're using metric.
They actually put everything right.
Let's use Kelvin and boils.
Yeah, just use Kelvin.
Why?
Because that's what.
Is that?
All right. Any questions about this?
Is it over?
Okay.
Is it over?
Yeah. Now let's talk about our last type of variation. No, just kidding. Just kidding. Everybody say bye to YouTube.
I am. Out of the reverse.